So what we'll see today is reactions involving gases. Before understanding reaction involving gases, so far you have seen all reactions in which solids were involved. So we know about a concept called molar mass. Molar mass as a concept is known to us. In plain language, what is molar mass? Mass of 1 mole. Okay, this is nothing but mass of 1 mole. So we used to calculate based on this. We used to molar mass is always expressed in molar mass will always be in grams per mole. Mass of 1 mole. So we used to use it as a formula. We used to use number of moles. N is equal to given mass over molar mass. Molar mass if you are actually using a atom, molecular mass if you are using a molecule. This much is what we used to work with so far, right? Nothing great. Molar mass means, like, say for example, if you're getting confused, if I ask you what is the molar mass of oxygen, you will say molar mass of oxygen is 16 grams per mole. That means, yeah, good evening. Why are you late, beta? The class is at 5:30. 1 mole of oxygen atoms are going to weigh how much? 16 grams. You come from the same society. How can you be late? 1 mole of oxygen atoms will give you 16 grams. Are we fine? Right, fine. Now, when we are doing with gases, we come to a new concept called molar volume, because gases have nothing called mass. Molar volume. Okay, molar volume. Molar volume means this is the volume occupied by 1 mole of a gas. What is the volume occupied by 1 mole of a gas? Now, what is the mass of 1 mole of say atoms? Very easy. You have the periodic table with which you are getting this data. What is the mass occupied by 1 mole of atoms? You use the periodic table. Now, how do we get to understand what is the volume occupied by 1 mole of a gas? So here, what comes into our rescue is Avogadro's law. Avogadro's law. Before understanding Avogadro's law, we should also understand. So this is our prelude. ये पुराना वाला discussion था. Okay, इसको छोड़ा कर देते हैं. Okay, let's make it small and keep it aside. Okay, this was all about molar mass. Before understanding Avogadro's law, we need to understand two concepts. One is, how do you quantify Avogadro's law? Because if you see it in CBSE, you will find there is a difference in the figures. Okay, now in Cambridge, everything about Avogadro's law, whatever data we'll take it at RTP. RTP stands for room temperature. Okay, room temperature and pressure. And the room temperature that they have taken is based on IGCSE announcements, the room temperature prevailing in England. Okay, so they have taken the room temperature as 25 degrees centigrade. Okay, 25 degrees centigrade is 298 Kelvin. Do you know Kelvin and centigrade conversion? Okay, अच्छा Kelvin centigrade नहीं पता है. Okay, अभी absorb करो, यहाँ side में बताता हूँ. And so room temperature and pressure, and the pressure is taken as 1 atmosphere. And 1 atmosphere is equal to something 101.3 kilopascals. Okay, kilopascals. I'll explain these. So just note this down. Everything that we do in Cambridge is done at RTP, whereas in CBSE we work this out in NTP. So it's at RTP. So when we classify Avogadro's law, we will be classifying Avogadro's law at room temperature and pressure. And the room temperature standard this room temperature that has been picked up is 25 degrees centigrade and 1 atmosphere pressure. 1 atmosphere is correct because everywhere 1 atmosphere is the pressure which is right now prevailing. Right now on top of your head you have 1 atmosphere as the pressure. ठीक है, इसको थोड़ा समझ लेते हैं ये कहां से आता है. Right. So let's say this is 0 degrees centigrade, which is the freezing point of water. This is 100 degrees centigrade, which is the boiling point of water. Now this is in degrees Celsius. This is known as the absolute temperature scale, absolute scale. And in SI units we use Kelvin. As per Kelvin, 0 degree is 273 Kelvin. Actually, it's 273.15. 273 Kelvin is 0 degree. So 100 degree should be how much? 373 degree. Okay, not degree, 373. We don't use the word degree. Okay, 373 Kelvin. Now, if you want to come at 0 Kelvin, which is the absolute zero, do you understand what is absolute zero? Below this, you cannot cool anything. Absolute is the last temperature that we can attain. It's linear, so it should be minus 273 Kelvin, degree centigrade, sorry. Minus 273 is the last temperature that you can reach. This is called absolute zero concept on the absolute scale. The beauty between these two scales is that if you see the difference, okay, so we have temperature at what, beta? 25 degrees centigrade. That corresponds to 25 you add with this, so it becomes 298 Kelvin. Understood? 25 to 26 degrees. उधर मत देखना, इधर देख, वो घर में पढ़. Don't fumble your eyes, otherwise you will not understand. And not required. You pay attention here. We have passed out our whole life without calculator. That calculator part will be snatched away from you in your exam. So why are you looking at that? They will not give you that part of the calculator. इधर देखो ना. 25 degrees correspond to 28. 26 degree and 25 degree, how much is the temperature difference? 1 degree. 26 degree will be how much? 299 Kelvin. So when you work on difference of temperature, this we will be using in physics. That's why pay attention here. The difference of temperature will always remain the same. 25 degrees and 26 degrees, the temperature is difference is 1 degree Celsius. And the difference here also will be 1 Kelvin. ये देख लो. 25 degrees centigrade means how much? 298 Kelvin. 26 degrees Celsius means how much? 299 Kelvin. If you see the difference here, then the difference is 1 degrees. The difference is 1 Kelvin. So if you are working on difference of two temperature, you need not convert the unit. That's what it means. But if you are working directly on the temperature, then you have to convert the unit. That headache will not come here. That headache will come in physics. Why have I told you about this? I have told you about this because everything that I'm going to speak or we're going to talk about Avogadro's law in Cambridge, in IGCSE, has been done on the basis of room temperature and pressure. What is the standard room temperature? 25 degrees centigrade. And what is the pressure? 1 atmosphere. 1 atmosphere corresponds to 101.3. You want to see how this also comes? You know this formula, right? Pressure is equal to rho into G into H. Rho means we are using mercury. Mercury's rho is 13.6 into 10 to the power 3 kg per meter cube into G 9.8 into the height that mercury rises is 76 centimeter, which is 0.76 meters. Now, if you do this, you will get your value in pascals. Mercury is for using for stand. Barometer uses mercury. Mercury is used for atmospheric pressure measurement. You can't use water. Water होने से height climb बहुत ज़्यादा हो जाएगा. Mercury climbs to a height of 76 mm. Clinical pressure measurement always happens in mm of Hg. I have taught you this. Pressure के क्लास में आप आए नहीं हो, आपने वीडियो नहीं देखा है, तो ऐसा ही होगा. ठीक है? So no repeating any content because the video watching is still very poor. Anyways, you may have your reasons for your exams right now, so I also will not say anything. But backlogs, if they are not clear, then you will not understand anything about physics right now. Okay, fine. So I'm taking these things off. This we have understood. Okay. What does Avogadro's law tell us? Why is Avogadro's law important? Avogadro's law is important. Otherwise, we cannot talk about something called molar volume. We will not be able to speak about molar volume. And molar volume is very important when we are seeing equations with gases. Molar volume is of utmost importance when we are seeing gases. Now, what does Avogadro's law tell us? Avogadro's law tells us that equal volume of gases at RTP, that is 298 Kelvin and 180 A pressure contain equal number of particles. ऐसे समझ में नहीं आएगा, अभी स्टेटमेंट को हाथ में रखो. Equal volume of gases means if I have a gas A, this is in gaseous form, and if I have a gas B, which is in gaseous form, if you have say x meter cube of this, and if you have x meter cube of this, and say right now the prevailing conditions are RTP, then they contain equal number of particles, means the number of moles that will be for gas A should be equal to the number of moles that will be for gas B. This is what is Avogadro's law. Equal volume of gases at RTP contain same number of particles. Okay? But this becomes more clear from the next statement that we will give. The next statement says 1 mole of a gas at RTP contains or not contains, the word should be occupies a volume of 24 dm cube. अब dm cube को भी समझेंगे. 1 mole of a gas at RTP occupies a volume of 24 dm cube. Okay, 1 mole of a gas at RTP occupies a volume of 24 dm cube. Let us understand what it is trying to say. And then we will marry with that. It tries to say that if you take an example, let's say 1 mole oxygen gas and let's say 1 mole nitrogen gas, these are both are gases. At RTP, oxygen will occupy 24 dm cube of volume, nitrogen will also occupy 24 dm cube of volume. Very interesting है ये law. It looks easy, but it's not that easy as you're thinking. 1 mole of oxygen, now this tells you about the size and density. If you take 1 mole of oxygen, then at RTP it will go to occupy 24. 1 mole of nitrogen will occupy 24. 1 mole of hydrogen will occupy 24. 1 mole of so and so will occupy 24. Just that the particle sizes are different. Okay, we'll try to understand. Now see whether this is getting satisfied. Equal volume of gases. Let's say we take the volume as 24 dm cube and we take the volume as 24 dm cube. Under the prevailing condition of RTP, this should contain 1 mole. This should also contain 1 mole. Do you now understand how this Avogadro's law is supported by Avogadro's hypothesis? Equal 1 mole of a gas. Now let us try and understand. This is say 24 dm cube. Let's say this is 24 dm cube. This is also 24 dm cube. And let's say this is a sample of oxygen. This is a sample of nitrogen. Agreed? Both occupy how much volume? 24 dm cube. Right? Both contain same number of particles. 1 mole each. That means inside here, how many oxygen molecules are there? 1 mole. How many nitrogen molecules inside here? 1 mole. Sir, then what is the difference? Oxygen, nitrogen are not same things. Whose atomic mass is more? Oxygen's atomic mass is more. Yes or no? So oxygen as an atom size will be bigger in sizes. Oxygen atoms are a little bit bigger. Obviously, oxygen's atomic number is 8. Nitrogen, thoda chota rahega. But the count will be exactly same. The count will be exactly same. 6.022 into 10 to the power 23, 6.022 into 10 to the power 23. This one also occupies 24 dm cube. This one also occupies 24 dm cube. 1 mole, 1 mole. Yeah.
So, if it has the same number of particles, but one is lesser, how will the volume?
No, nothing is lesser. Volume is same. Same number of particles. Sizes are different. sizes are different. Sizes are different. Same number of particles, they occupy the same volume. Suppose there is a slim child and there is a little bit bulky child. 10 children, 10 bulky children in that room and 10 slim children in that room. They occupy same volume. हेवियर कौन सा रूम होगा? बल्कियर वाला रूम. वो लोग चिप चिप के है, लेकिन they are also consuming how much? 24 dm cube. Slim children are also consuming 24 dm cube. Yeah, बोलो.
Yeah.
No, not less particles. हाँ, वो हो सकता है. Nitrogen may be more खुला खुला, whereas 10 bulky children will be more stacked to each other. समझ में आ रहा है ना? तो डेंसिटी ज्यादा हो रहा है ना इसका. समझ में आ रहा है? जिसका मास ज्यादा उसका डेंसिटी ज्यादा. डेंसिटी इज इक्वल टू मास पर यूनिट वॉल्यूम. Is this law getting clear? Avogadro's law tells me that equal volume of gases at RTP contain equal number of particles. That means if you are at RTP, please understand, let us not make it 24. Now let's say 100 dm cube. I have got 100 dm cube of a gas called argon, and I have got 100 dm cube of a gas called neon. What is the room temperature? Sir, 298 Kelvin. What is the pressure? 188. Then the number of neon particles and the number of argon particles must be same. Now we are not talking about 1 mole. The standard is if you have 1 mole at RTP, then the volume occupied is 24. Have you understood? 1 mole occupies how much? 24. In CBSE, we read this as 22.14. Because there we do the problem on NTP. This definition will be different. Like Avogadro's hypothesis here, how do we read? 1 mole of a gas under the conditions of RTP occupies how much? 22? Not 22. See, yes, the 22 comes easily to my mouth because we are habituated. 24 dm cube. और CBSE का बच्चा क्या पढ़ेगा? 1 mole of a gas at NTP contains 22.14. So 22.4 and 22.1. So we will go by 24 dm cube. इतना समझ में आया? अब आते हैं बात थोड़े से कन्वर्शंस में. ठीक है, इसको छोटा कर लेते हैं, रख लेते हैं. So nothing is difficult out here, only that you're going to absorb a lot of conversion data. So be very careful with your conversions. I'm making it smaller now, keeping it here. Fine. If you feel that anything you have not understood, tell me and we can come back to it. Right. Let's now go to that dm cube wala funda. Let's try to understand dm cube. Dm cube, yes. Okay. We are talking about volume. The usual units of volume, if you go by SI unit of volume, then the SI unit of volume is what? Meter cube. Clear? Another unit which we constantly hear about is liters. Liters. So we should understand what is 1 liter. 1 liter is the volume of that cube whose each side is 1 dm, 1 dm, okay, whose sides are 1 dm. ये समझ में आया 1 liter का definition? 1 liter is the volume of a cube whose sides have a measurement of 1 dm. That means, children, can I write 1 liter is equal to 1 dm into 1 dm into 1 dm? Can I write this? Obviously, the volume of that cube. So what is the volume of this cube? 1 dm cube. Perfect. Now, if you want to convert this dm, how do you convert? Just look here, milli, after that centi, deci, this is your dm, okay, and here is your meter, milli, centi, deci. So let's come down to centimeter. Can I write 1 dm as 10 centimeter? Just look here, 10 centimeters, right? Can I write this also as 10 centimeter? Can I write this also as 10 centimeter? That means 1 liter equals to 1000 cm cube, which is also equal to 1 dm cube. This is a very, very important conversion that should be at your lips. Usually in Cambridge, you will get your volumes in dm cube, but there will be some problems where it will be in centimeter cube. So 1 dm cube is same as 1 liter, and 1 liter is 1000 centimeter cube. Keep this in your mind. And if you want by meter cube, then 1 meter cube is equal to 1000 liters, which is equal to 10 to the power 6 centimeter cube. 1000 liters means 1000 dm cube. ये उतना जरूरी नहीं पड़ता है, but this is very easy to understand. Think about a cube whose each side is like the meter stick in a cloth shop. जितना बड़ा. Inside that, 1000 numbers of water bottle can be fitted. 1 liter water bottle can be fitted. ठीक है? ये हमें बहुत जरूरी पड़ेगा. ये लिख के रख लीजिए. Molar volume. So what is the molar volume? Molar volume is volume of 1 mole of a gas. Let's do one small problem. And can I wipe this part off then? All of you fine? Can I wipe this off? Okay. Let's do a small problem. And before going with the problem, let's keep our recap, whatever we learned so far. What is the recap? Our recap is 1 mole of a gas at RTP occupies how much? 24 dm cube. This you remember. 1 mole of a gas at RTP will occupy 24 dm cube, and 1 liter is equal to 1 dm cube is equal to 1000 centimeter cube. This we will need in the next section. So let's take a problem now. And the problem is 8 gram of sulfur are burnt. What is the volume of SO2 produced? So the reaction is about sulfur. Okay, you are having sulfur and you are burning sulfur. You are burning sulfur. So obviously what should be the output? Sulfur dioxide. Sulfur dioxide. This should be the reaction. So let's first write our reaction. Sulfur as solid reacts with oxygen, right, as gas, and produces what? Sulfur dioxide, which is also gas, right? Our question is, if 8 grams of sulfur are burnt, then what is the volume of sulfur dioxide that is produced? You are burning 8 grams of sulfur. 8 grams of sulfur. देखो ये प्रॉब्लम ऐसे मत करो, ये डायरेक्टली आपके मुंह से हो जाएगा. देखो, it can be done orally itself. Let's see how we can smartly do this problem. Think that you don't have a calculator. Let's see how to smartly do the problem. Let's come to molar calculation. 1 mole of sulfur atoms react with 1 mole of oxygen gas to give you 1 mole of SO2 gas. Are we absolutely clear about it? No doubt, no doubt. How much is 1 mole of sulfur? 32 grams, right? 32 grams. So 32 grams is reacting. 32 grams correspond to how much? 1 mole. How much is in our problem? How much of sulfur is being reacted? 8 grams. So 8 grams is how much of 1/4? So 8 grams should straight away give me how much? 8 grams means how much of mole? 1/4 mole. 32 grams is 1 mole. So 8 grams is 1/4 mole. 1 mole gives 1 mole. So 8 grams will give how much? 1/4 mole of SO2. Right? At this step, think of Avogadro's law. Avogadro's law tells me 1 mole SO2. SO2 is a gas? Yes. At RTP should have how much? 24 dm cube. You are left with how much? 1/4. So you make it 1/4. इसको भी 1/4 कर दो. So you should have how much? 60. Is it fine? At RTP. Clear? Shall we try to do one more problem now? Is this problem understood? First of all, see whether you have understood or not. You try to do it on your own, Akbar, using unitary method. 32 grams of sulfur, 1 mole reacts with 1 mole to give you 1 mole. So 32 grams correspond to 1 mole. So 8 grams will correspond to 1/4 mole. Is this clear, Nidhi? Right. Let's take one problem now. Kar lo isko. We'll take time. We'll do everything on our own. Kar lo. Done. Is the logic understood? Whenever they say 8 grams of sulfur or something, wait, before doing the problem, always check what is the molar mass of this. And agar dekhoge straight cut off ho raha hai na, it is just an intelligent problem. You don't need the calculator at all. Take. Shall we take another problem? Mitaye isko? Can I rub it? Okay. Copy it. Fine. Chalo, mitaya, huh? Okay. Let's take our next problem. And our next problem is, based on this, you all try it. 22 grams of carbon. 22 grams of carbon nahi ho sakta, carbon dioxide. So we have 22 grams of carbon dioxide. It occupies how much dm cube at RTP? देखो ये भी interesting question है. 22 grams of CO2. First try to find out the molar mass of CO2. I know molar mass of CO2 is always 44 grams. 44, 12, carbon is 12 plus 16. Okay. Now, sorry, 32. 12 plus 32. Carbon is 12 and oxygen is 2 of oxygen. So this is 32. 44. 44 grams means how much? 44 grams CO2 means 1 mole CO2. Yeah, in your question it is given how much? 22 grams CO2. So how much do you have? 1/2 mole. Avogadro says 1 mole at RTP should have 24 dm cube. Therefore, half mole should have 12 dm cube. समझ में आया? Next वाला कीजिए. Try to do the next one. Next one is calculate the mass of sample of nitrogen gas. The nitrogen gas, I have got nitrogen gas, N2 as gas, and I have 36 dm cube at RTP. 36 dm cube of nitrogen. ठीक है? नाइट्रोजन को करो तो कितना रहता है? 7 नहीं, 14. 14 का डबल करेंगे यहाँ पे, कितना हो गया? 28. So 36 dm cube nitrogen. You have got 36 dm cube of nitrogen at RTP. So what is the basic equation? 1 mole nitrogen at RTP should occupy how much? 22. Oh, sorry. 24. 24 dm cube. Have you understood? उल्टा करो इसको. 24 dm cube corresponds to 1 mole. So 24 dm cube of nitrogen at RTP gives you 1 mole of nitrogen gas. Therefore, 1 dm cube gives you how much? 1/24 mole. And you have got how much? 36 dm cube. So 36 dm cube of nitrogen will give you 1/24 into 36. 12 2s are 24, 12 3s are 36, 1.5 mole. Okay, now we have to find out what is the mass. 1 mole का mass कितना है बेटा? 1 mole's mass is 28. Therefore, 1.5 mole का mass कितना होगा? 28 plus another 14. So it should be 42 grams. Very good. You have understood. Trick समझ में आ गया है आपको. Clear? Kirtan understood? Which one? 28 plus 14. See, 1 mole is having a mass of 28. 1 kg mango costs you 30 rupees. 1.5 kg will be 30 plus half of 30. 30 plus 15. So 28 plus half of 28. 14. Is it clear now? All else you can use your calculation. 1 mole is 28. So 1.5 is what? Multiply 28 with 1.5. You'll get the same answer. But using the calculator for these problems would be a little bit stupid. Okay, let's go another problem now and see a complete gases problem. Though it's a worked out example, but we'll try to do it. We're seeing the reaction of formation of hydrogen chloride. So hydrogen chloride formation, we will have hydrogen as a gas reacts with chlorine as a gas to give you hydrogen chloride as a gas. So let's balance it. 2HCl, this is in gas, this is gas, and this is gas. So what does the standard reaction tell me? All of them are in gases. That means 1 mole reacts with 1 mole and produces 2 mole. 1 mole reacts with 1 mole, produces 2 mole, right? So if we go by volume, if the reaction is happening at RTP, that means you have 24 dm cube of hydrogen reacting with how much? 24 dm cube of chlorine, producing how much? 48 dm cube. Exactly correct. 48 dm cube it produces, and it produces 48 dm cube of what do you call this HCl. No, that's not a question. It's just to explain you. Abhi question aayega. We'll go by concentration, then the interesting questions will come. And many times we also try to see this equation in volume parts. Volume parts means we say, like used to say 1 mole, so we say 1 volume. 1 volume means you understood. जैसे say illiterate person, 1 गिलास दूध लेंगे, so half glass चाय मिलाइए. 1 volume reacts with 1 volume, gives you 2 volume. Simple. Okay, so this is understood. Now let's understand something about molar concentration. That's another topic. Then only we will understand acid-base titration. Molar concentration, or rather we call it concentration. So concentration can be mass concentration. So right now what we are talking about is molar concentration. Whenever you talk about concentration, children, you are talking in terms of something called solution. A solution has 2 parts, something which is known as a solute and something which is known as a solvent. You know the difference between 2? Okay, there are 2-3 ways. Number 1 is, one who is present in less quantity is always the solute. One who is present in more is always the solvent. Second, after the solution has been made, whatever is the state of the solution, check it, and whichever of them has the same state as that of the solution, that is the solvent. What I'm trying to say is, let us take sugar. Let's take sugar, which is obviously solid, and let's put sugar in water, H2O. This is liquid. So what does it become? Sugar solution. If you mix both of them, then what do you get? Sugar solution. Now, what is the state of sugar solution? Liquid. Out of the 2, who was liquid? Water was liquid. So water gets to be known as the solvent. Now, if you tell me, sir, if I mix blood out here, blood and water, then who is the solvent? The one who is less in quantity is known as the solute, and the one who is more in quantity will be known as the solvent. Third way to understand is, the one who gets dispersed in other, जिसमें मिल जाता है, घुल जाता है, that is known as the solvent. Sugar is getting dispersed where? In water. So water is the solvent. Clear? नहीं नहीं, वो उसका बढ़िया example. Take one bag and this is a bag of sugar. Okay, what is the state? Solid. And I tell Nidhi that take one injection syringe and you plunge some water in it. So she has put water in it. What do you expect after 5 drops? The sugar bag will still be sugar bag. What is the final state? Solid. Out of sugar and water, who was solid? Sugar was solid. Sugar is solvent. Water got lost in sugar. So water is the solute. ठीक है? Clear है? Okay, चलिए. तो ये portion अगर आपको clear है, so we need to just understand here, because we would be getting solutions, and in our solution it will be very simple. The solvent is always water, because you will be having aqueous solutions. Aqueous solutions बनाएंगे, but the solvent will always be water. However, solute can be of 3 different types. Solute can be an acid. In that case, will I call it an aqueous solution? No. Dilute acid. Dilute acid, dilute base, and an aqueous solution of a salt. देखो तो बच्चा ये समझ में आया कि नहीं? We are going to have a solution, and the solution will be comprising of solute in the form of acid. If acid is the solution, then what do I call the solution as? Dilute acid, dilute base, and aqueous solvent, aqueous solution of a salt. Have you understood? Now, molar concentration. Whenever we talk about concentration, whenever you talk about concentration, whether you are speaking it in terms of mass concentration, molar concentration, you are always comparing it in terms of solution. Always in terms of solution, not in terms of solvent. Many children do this mistake. Solvent. And on top, we will always have solute. Now, what are we studying? Molar concentration. So, we will see the moles of solute over volume of solution expressed in dm cube, or it is same as liters. Hang on 1 minute. If it was mass, this is known as what, beta? Molar concentration. If it was mass concentration, it will be mass of solute over volume of solution. Grams per liter. Grams per liter. Okay? So this is called molar concentration, and this molar concentration is also known as, in terms of chemistry, we call this as molarity. Molarity, though you are not using the word, and we denote it as M. M, capital M. Capital M stands for what, beta? Capital M stands for moles per dm cube, or we can say capital M stands for moles per liter, or it can also be capital M also stands for, अगर आप यूनिट में क्लियर हो ना, आपका सब कुछ क्लियर है. 1000 cm cube. All mean the same, because I know 1 liter is 1 dm cube is 1000 centimeter cube. Is this clear? Molar concentration. Whose concentration are you searching? Moles concentration. In what? In a solution. What are you trying to find? Moles of solute. Moles of solute present in volume of solution. Achha, how do you find volume of solution? Volume of solute plus volume of solvent. है ना? इतना आपको complex नहीं करेगा. So, solution volume is always equal to solute volume plus solvent volume. ठीक है? Understood? चलिए आगे. Anyone has any query on this step? Molar concentration. How many moles in the solution per unit volume? And sir, in what unit will you measure the volume? dm cube or liter or 1000 centimeter cube. All mean the same. But you can have no authority to change it to meter cube. It's always dm cube, dm cube, dm cube for you as a IGCSE. But in your mind, dm cube is same as liter, 1000 centimeter cube. Okay? Chale? Okay, let's now go a little bit more ahead. So we have understood What is mass concentration? So mass concentration will be grams per dm cube. Volume concentration. Anyways, the book has also written about mass concentration. So let us also write about mass concentration. Mass concentration is given as mass of solute over volume of solution. Mass of solute will be measured in gram and volume of solution will be in dm. Okay? That was moles per dm cube. This is grams per dm cube. Okay. So let's pick up some questions. Automatically we will understand. Now let's see. For example, how many moles of sugar? Okay, we're trying to find out now. We're trying to find out how many moles of sugar, how many moles of sugar are present are there in 500 centimeter cube. So let me make it properly. Okay, sugar are present in 500 cm cube. Children, when you read about 500 cm cube, what should strike your mind? Half liter, very good, or half dm cube. Remember this, it should strike your mind because 1 dm cube is 1000 centimeter cube. Okay, 1000 centimeter cube of a 3.0 mole per dm cube sugar solution. पहले क्वेश्चन को समझते हैं. जितना you will understand this question, that much you will be clear in doing problems. Okay. Now this part is very important. This part is important. This in our chemistry we call as strength of the solution. Strength of solution. They are trying to tell you how sweet it is. Strength means the intensity. Now obviously this is a sugar solution, so it will be sweet. This is a fundamental measurement. This solution has been made with 3 moles in every liter. So let us look at the master solution that we made. We must have made it in some, say, big bucket. And let's say this bucket holds 1 dm cube solution. Let's say it holds 1 dm cube solution. Try and understand. In this 1 dm cube, how much of sugar was there? 3 moles. Have you understood this thing or not? We are having a big party where we are going to give sugar syrup to everyone. So we have made a mother solution. The mother solution has been made in a big tumbler, which can take how much? 1 dm cube. So in 1 dm cube, how much of sugar is there? 3. This is the master solution. Now, will you serve in this to anyone? No. You will be giving in glass or katoras. But tell me, if I give Dhruv in a bigger glass and if I give Kirtan in a smaller glass, will the taste be different? No. Because the strength of the solution is fixed. Have you understood? Now from here, you have taken a vessel where there is half dm cube. The solution is how much? Half dm cube now. Now they are asking you, how many moles of sugar do you expect here in half dm cube? Exactly half of that. So I expect 1.5 moles of sugar out here. तभी ना अपना टेस्ट बराबर रहेगा. टेस्ट देखो. In 1 dm cube, 3 moles are there. Half dm cube, half mole should be there. Half of this. Half means half of 3. So 1.5. Then only the taste will remain the same. Are we fine? Anyone who has not understood this, because these tricks you have to apply a lot when you are doing problems. जब भी आप problem कर रहे हैं ना, ये tricks आपको बहुत apply करना पड़ेगा. You have to apply these continuously. You have to think. Right? So children, please understand. Before this, you understood everything with mole level in solids. Then you understood something called molar volume. Molar volume opened the Pandora's box of Avogadro's law, which says equal volume of gases at RTP contain equal number of particles. And what's the benchmark? 1 mole of a gas at RTP will contain 24 dm cube, and the RTP is 298 1 atmosphere. Okay, right? So let's take up one more problem. And please get into previous year's question and solve as many problems as you can, because next chapter also we have questions, but this is the most dicey ones that you can get. Okay, in fact, you after this you should be able to solve CBSE grade 11 problems also. They are at par with this course, and since you have a calculator, nothing wrong. We'll solve some problems from there also. Okay, calculate the concentration of a solution of sodium hydroxide. So our question is all about a solution of sodium hydroxide. So it's about NaOH, which is aqueous. So beta ye kya ho gaya? This is sodium hydroxide solution. Do you understand what do you mean by solution? Sodium hydroxide is mixed in water. So we have to calculate what? You need to get me the concentration of this one. Concentration. That means your answer finally will be in moles per dm cube. So you are basically trying to give me the molarity of this solution. In other words, you will be giving me the final answer, which will speak about what is the strength of this solution. Am I fine? No, data I have not given you still now. Mass concentration is also there, but this is molar concentration you have to answer. Let's see what is the question all about. Now, calculate the concentration of a solution of sodium hydroxide that contains this solution contains 10 gram in 10 gram what? NaOH in 250 in a final volume of 250 centimeter cube. Children, looking at 250, your eyes should lit up as 1/4 liter or 1/4 dm cube. Understood? So what do we need? We need concentration. Concentration is given as moles of solute. Okay, we'll calculate both. First, we are trying to calculate molar concentration. We'll go the tougher way. Okay, calculating mass concentration will be very easy. Okay, let me write mass concentration first. Mass concentration will be given as mass of solute in what beta? Grams divided by volume of solution in cm cube, right? Or dm cube as you want, or we'll keep it as dm cube. We'll keep it as dm cube. Volume of solution in dm cube. Let's calculate this first, mass concentration. So mass of the solute is how much? 10 grams. 10 grams divided by 1/4 dm cube. So kitna ho jayega? 10 divided by 1/4. So it becomes 40 grams per dm cube is my strength of the solution or mass concentration. Okay? Now what are we going to find out? Molar concentration. So molar concentration is moles of solute over volume of solution in what beta? dm cube. What is the volume of solution? 1/4 dm cube. Now moles. Come back to your main formula. What is number of moles? Given mass by molar mass. What is your given mass? So this is given mass over molar mass. You can't forget anything. So given mass is how much beta? 10. 10 divided by how much is this? Sodium. Sodium is 40. NaOH is 40. Yeah. Hydrogen 1. Sodium is 40. Correct. 10 over 40 divided by 1/4. So this becomes 10 over 40 into 4/1. So 4 tens are 40, 10. So it's 1 mole per dm cube. And in other books, you will see written as 1 molar solution. 1 molar solution. तो आपने दोनों निकाला, mass also you found out this also. Clear? If this is clear, all of you have copied it? अश्मिता बेटू मिटा सकता हूं? Okay. Now I will not help you. You do on your own. I want to find out the molar concentration. Okay. Molar concentration. You need to find out, bacha. Of what? Solution which is having 14.3 hydrated sodium carbonate. Okay, hydrated. This has got water of crystallization. Na2CO3 dot 10H2O. This is washing soda, hydrated. And how much of this? 14.3 grams. I have 14.3 grams. Be very careful, huh? 14.3 grams of sodium carbonate, and this is in 500 centimeter cube of distilled water. How much will you take volume of solution now? सॉल्यूशन होता है, सोल्यूट और सॉल्वेंट दोनों मिलके वॉल्यूम होता है. According to me, don't you think that 10H2O should also contribute some volume? But I don't think in your book they will be going to that level. Otherwise, they should have given. See, the right way of doing this problem is Na2CO3 dot H2O. If this would have been another liquid, इसका density दिया हुआ रहना चाहिए. इसका भी तो एक volume होगा ना? हाँ. So they are thinking that it will be negligible, almost negligible. So you can take the volume as 500 itself. So 500 means how much? 500 means how much? Half dm cube. Now try to find out molar concentration. So molar concentration is always number of moles over volume of solution. What is the number of moles given mass by molar mass? अब यहां पे इंटरेस्टिंग है, वॉल्यूम ऑफ सॉल्यूशन तो चलो आ गया हाफ डीएम क्यूब, गिवन मास बाय मोलार मास. गिवन मास कितना है? 14.3 डिवाइडेड बाय मोलार मास. हाउ विल यू फाइंड आउट द मोलार मास? सोडियम क्लोराइड कार्बोनेट का कितना आ रहा है? देखो 106, वाटर का 18, बट 10 ऑफ वाटर 180, 106 plus 180, 286 है कि नहीं? 286. So this will finally give you the answer. Okay, fine. Now the most interesting part, acid-base titration. We'll just tell you about the theory. We may not be able to do problems today. So the theory समझ लेते हैं. Okay. चलें आगे. ये तो समझ में आ गया शायद. Okay. Before going to acid-base titration, okay, now you're going to see titration. Titration means acid and base. So this is a fight between Asura and Devata. The demon and the gods are going to fight. It's a neutralization reaction. So let's first understand what is a neutralization reaction. Let's take HCl, which is in aqueous mode is an acid, reacts with NaOH on aqueous mode, base, and it will give you what? Salt, which is aqueous, and it will give you water. This is plain reaction that we know. Okay. And in molar form, we'll say 1 mole reacts with 1 mole to give you 1 mole and 1 mole. Understood? Now, 1 mole reacts with this. Now, in a lab, when you have a test tube and say I have given you dilute HCl, right? So obviously, to some level of the test tube, I must have filled it up. Say I've filled it up till this level. So you know what is the volume of HCl that you are carrying. You can measure it up, not in a test tube, but in a measuring cylinder, you can measure it. You don't know anything about the strength. The strength is not known to you. Strength, aapko nahi pata. How do you know there is 1 mole or 2 mole? After all, we don't know, right? Now, say this HCl, you are now trying to react with another sample of NaOH. And same is your problem in NaOH also. You just know a bit of volume and you don't know the strength. You don't know the strength. So you won't be able to comment on the strength of either unless and until the person who gave you this sample reveals the secret to you. Otherwise, you have no other way. आपके पास कोई रास्ता नहीं है to get the strength of this and to get the strength of this. Do you understand? This is a theoretical reaction. The theoretical reaction says 1 mole reacts with 1 mole. How do you know how many moles are here? How do you know how many moles are here? You cannot get it. Nobody will be able to get it. But somehow, if the strength of one solution is known, then you can find out the strength of the other. This basic thing is known as titration. Titration means you are actually titrating. Titration is simple. Bring one enemy in front of me, and I will bring different of my warriors to fight with him. The warrior with whom he locks his horns on is the strength of that enemy. And I know the strength of all my warriors. First, I will send warrior 1, go and fight. Warrior 1 got killed. So he's much more powerful. Then I send warrior 2, warrior 3. At warrior 7, there's a lock on. Nobody is able to win. Strengths are equal. And I know my warrior 7 strength. Can I now comment on his strength? Yes, very well, I can comment on his strength. Have you understood? That warrior whom you sent to fight with him, whose strength was known, in this language we call him as a standard solution. Standard solution is someone whose strength is known to you. ठीक है? तो ये इसको भगाते हैं, and let's understand something called, so we will have a solution A and we will titrate it with a solution B. This is the whole game all about. Solution A versus solution B, in which, let's say, the strength of B will be unknown to you. We don't know. And the strength of A will be known to me. Strength of A will be known to me. How do I find the strength of B? Based on the strength of A. Okay? I think we will stop here, because if I teach anything here, it will be half-hearted for 2 minutes. You all have exams tomorrow? Okay. If I teach now also, it will go for half-hearted and I won't be able to finish it in next 10 minutes also. So we'll take it up in the next class, right? How to go with solution A and solution B. Just remember, so up till now, except acid-base titration, take up exam papers and try to do molar volume questions as much as you can. Titration we will do in our next class. Okay? So what is titration all about? Titration is all about finding quantitatively the strength of another solution when you titrate it against a standard solution. Titration is about finding the strength of the demon when you make him fight with known strength warriors. That fight is known as titration. The known strength warrior is known as the standard solution. एक standard solution के साथ titrate करेंगे किसको? एक unknown solution को, और उसकी strength निकालेंगे. ठीक है? चलते हैं, यहाँ रखते हैं, अगले क्लास में हम इससे आगे बढ़ेंगे।